right, welcome back to Everything Mathematics. And today we're going to continue our series on basic algebra that we would have started yesterday. And today our focus will be again, how do we operate whenever we're dealing with multiplication of algebraic terms. Unlike yesterday, I would like to start this one by telling you, this is where maths start to become abstract. Because, well, not start, to be honest, there are a lot of things in maths that are abstract. But when I say abstract, in the sense that we could relate to this mathematically speaking, but it's pretty hard to draw a scenario to this in real life mathematically. And that's just one of the things we have to start acknowledging when it comes to mathematics. Not everything could be realistically demonstrated, but we know it is a reality based on the nature and the function of whatever is it that we're doing. And I'll explain why I say that. So yesterday we looked at, adding and subtracting algebraic terms. And we said, if we have 4a and we add that to 3a, we accepted that we get 7a. That's yesterday when we were adding. And the scenario we attached to this in real life was the fact that if somebody has 4 lines, good, and somebody else has 3 lines, I'm only using lines, mind you, that could be anything, right? We could have related that, okay, yes, 4 lines plus 3 lines is 7 lines. And there is no dispute there because this is, as I said, very relatable. But, and mind you, lines could have been anything. It could have been lines, it could have been pens, it could have been cars, it could have been pencil, it could have been boys, girls, anything you add in real life, you could actually have how should I say, an algebraic representation for that, and that could be anything you choose. If you want it to be the letter B, it could, C, D, E, it doesn't matter. Sometimes we just use that to represent something else. And understanding this, of course, would help you significantly when you try to come up with expressions on your own. For example, sometimes you get questions, the length of a given rectangle is represented as X meters long or whatever. They don't give you a dimension, but they give you a representation. And yeah, that's ways in which all these concepts of algebra plays a big role. But back to the point. When we dealing with this, when we dealt with this yesterday, there was not much dispute in the fact that we could see the relativity, we could see the relationship. However, when it comes to multiplying algebraic term, there is no relationship in real life. And look at it just like this. Sticking to what we learned yesterday. If somebody has 4 lines, think about this. If somebody has 4 lines, and you want to multiply that by somebody that has 3 lines, think about it. Do you think all of a sudden now you will end up with 12 lines? No, you would not. And that's the thing. In real life, this one here, as I said, it's very difficult, or maybe that's just maybe my inefficiency too. Maybe it could be that too. Maybe there's another relationship we could associate. Well, actually there is, because when we're dealing with things like areas and perimeters, I could show this. But not all the time it comes down to the geometry. Sometimes it just comes down to the basic understanding of what is happening. And in real life, it is hard to understand why 4 lines times 3 lines is 12 lines squared. That might be a little something harder to understand because in real life, you cannot really have 12 lines squared. Let's face it. I mean, if lines are able to multiply like that, I just send somebody and pick up 3, I go and pick up 4, and just like that, we just duplicate or exponentially increase it, if you want to call it like that. But yes, that's not how it works. So when it comes to the algebra, this is what you need to learn. Maybe I should do this on a clean side. So what you need to learn with this is that if you have A and you multiply that by itself, what you would end up with is A squared. That's it. When you're multiplying. Unlike yesterday, when you added, we learned that, of course, if you add A plus A, you will end up with 2A because you have 2 A's. But when you multiply now, it becomes exponential. You get an index. As a result, A times A is A squared. And what you need to understand is that this little 2 here is the same as really saying A multiplied by itself. Similarly, if we're using a number, 3 times 3 is actually 3 squared, which we actually saying that is 3 multiplied by 3, which is equal to 9. So of course, when we get a number, we could compute it. But when we get an unknown, the least we could do is just represent it algebraically. What you need to understand too, which is true, you wouldn't always be multiplying twice. You could be multiplying any amount of times. So what if I have, let's say, C multiply by C, multiply by C, multiply by C. That could very well be possible. So here we have C being multiplied by itself 4 times. So C by itself, C by C will give us C squared, times C will give us C cubed, times C will give us C to the power of 4. And that's how it works. That's how we do it. So C times C times C times C is C to the power of 4. We could have a number attached. And once we have a number, the concept goes back to what we learned yesterday. Common things for now, we put them together. And what is not common, for now, we'll leave it separate. Mind you, you could put it together. You could. For example, you could multiply A times B. Good? You wouldn't get one entity, but this will leave you with AB. You need to understand that. You could multiply 2 things that are not common and get a common result, or not a common result, let's say a single result. But for now, I'm going to keep it simple because we're learning the concept. What is I want us to build on the concept. So for now, I'll keep it simple. So for instance, if we have something like 9x, and let's say we are multiplying that by 3x, notice now, the x's becomes x squared. And the 3 times the 9, that will become 27. So 9x times 3x is actually 27x squared. And that's basically how, oh, sure, I don't know if I went there too fast. That is basically how we solve those types of equations. Good. So let's see if we could simplify a few problems and maybe call it the end for today. So simplify. And remember, by simplification, we simply mean that we're making the problem simpler. We're not necessarily solving. We could only solve if we know what are the unknowns. If we don't know what are the unknowns, it will be very difficult to solve. Let's try this one. Let's try another one. Supposing we have 9b multiplied by, that will be too simple. That will be too similar to the one that we just did. Let's try 7b. And let me give you one of those odd ones so that you'll start appreciating the fact that you could multiply 2 different things, but you just have to know how to manipulate them. So if we have 3y, let's say we multiply that by 2x, which is in turn multiplied by 4y. Of course, at this point, you could pause the video and solve, but I will just go straight ahead. So here, notice we have 3 a's. So right away, I know that we'll end up with a cube. And then we multiply the coefficient. The coefficient is the number that is in front of them. So 7 times 2 is 14. 14 times 1 is back to 14. So this is the answer for the first one. Second one, we have 9 multiplied by 7. And here we need to know our timetable. 9 times 7, I think, is what? 56? Is it 56? Not 56. No, hold on, let me double check. I forget that one. It's 42 according to my calculator. Yes, 42. 6 are 36 in truth, and then you just add 6 to 36 to get 42. Right, so here we will have 42b squared, pretty much as straightforward as that. And then you have, I'll show you this one in 2 steps. So 3y times 4y, that will give us 12y squared multiplied by 2x. And this is generally acceptable. Generally, we could leave the answer at that. Of course, at a lower level of maths, but as you go up higher levels in maths, you will know that this could also simplify to 24xy squared. Yes? When it comes to multiplication, this is acceptable. Notice, however, that the x and the y never becomes 1 because x is still x and y is still 1. Why? But when you're multiplying the entities, yes, this is a thing. In fact, if you learn the distributive law, for example, if you have A and the distributive law says B plus C, for example, you would learn that you could multiply A by B and you could multiply A by C, giving you a result of AB, even though A and B are not the same, plus AC. So that's all I did here. It's basically the distributive law. Picture the x and the y as two different unknowns, just as how b and c are different from a. So you could distribute in multiplication. The addition works a little different. You don't distribute like this when it comes to addition. When it comes to addition, you could only add something that is common to itself. That's why we cannot add complex numbers with maybe real numbers in some instances, because they're not on the same plane when you look at it when it comes to counting. So yes, this will be it for today. I trust this video helped you in one way or the other. Of course, if you don't understand, feel free to leave a question in the comment section below, or I could even target more difficult questions, because these really and truly are very straightforward. I'm just trying to teach the concept. But of course, in the future, feel free to ask whatever. Until then, you take care.